Welcome to the deep dive. You've sent over some really fascinating stuff today. We're talking lab-grown food, but like in space.
That's right. The BBC piece on the European Space Agency, the ESA mission. It's pretty compelling.
It really is definitely sparked my curiosity. So, okay, let's just dive in.
Sounds good.
This BBC article talks about an ESA mission launched April 22nd, 2025. No crew on this one, which is interesting in itself.
Right, an uncrewed mission. And its main goal, its sort of primary objective, was testing out food production.
Yeah.
Actually making food, up there.
Directly in space. And the why behind it is, well, it's pretty staggering, isn't it?
It really is the cost.
Yeah.
Keeping astronauts fed on the ISS, the International Space Station, it's something like 20,000 pounds per day.
Wow, 20,000 pounds a day.
Okay.
Yeah, that definitely puts it into perspective.
Exactly. Costs like that, well, they just demand you look for alternatives for different ways of doing things.
You can absolutely see why. So this mission, it wasn't about like setting up a little greenhouse with tomatoes and lettuce just yet.
No, not quite like that. Not in the traditional farming sense. Anyway, what's really innovative and kind of the focus here is producing the fundamental stuff.
The fundamental stuff.
Yeah, the core building blocks of food. We're talking proteins, fats, carbohydrates, the macronutrients our bodies need.
Ah, okay. So macronutrients, meaning, like you said, proteins, fats, carbs, the basics.
Precisely.
So instead of shipping up ready meals or trying to grow whole plants right away, which I imagine has its own challenges in zero G,
But definitely huge challenges.
they're aiming to create the sort of raw ingredients.
That's the idea. The article mentions using bioreactors.
Bioreactors. Okay, what exactly is that? Is it like a high-tech fermentation tank? Is that close?
That's a pretty fair analogy, yeah.
Yeah.
Think of it as a very controlled environment.
Yeah.
It's specifically designed to cultivate these essential macronutrients using biological processes.
Right, right. Controlled biological processes.
Hmm.
So these bioreactors are basically miniature food factories
Hmm.
in orbit, potentially churning out the basics needed for meals on, say, really long trips.
That's certainly a long-term vision, yeah. Imagine missions to Mars or even further out.
The logistics.
Exactly. The logistics, the sheer cost of constantly sending food supplies from Earth. It just becomes immense, maybe even prohibitive.
So being able to produce nutrients there on site, that would be a massive shift, a real game changer, like you said.
Absolutely. A complete game changer.
And it strikes me, it's not just about the cost, massive as that is, it's also about self-reliance, right, for the astronauts.
That's a huge factor, too. Independence. Not being totally tethered to Earth for basic survival needs on these, multi-year journeys.
Does it also maybe open doors for, like, better nutrition, tailored diets?
That's another potential benefit, yes. If you're producing the core nutrients, you could potentially tailor the nutritional profile, maybe adjust it based on the mission phase or individual needs.
Which might be harder with just prepackaged, long shelf life stuff.
It might be, yeah. Prepackaged food is amazing tech, but this offers perhaps more flexibility down the line.
Okay, so boiling it all down, this initial ESA mission, the one from the BBC report, it's like a proof of concept, a critical first step.
Precisely. Can we actually do this? Can we cultivate these fundamental components effectively in the pretty harsh environment of space? That's the question they're trying to answer.
And if the answer is yes.
If it's yes, it really unlocks a whole new approach for how we think about sustaining humans during deep space exploration. It's foundational tech.
Foundational. I like that. Paving the way for maybe a more sustainable, more independent human presence off planet.
That's the hope. Of course, there are big hurdles still. Scaling it up, ensuring long-term stability, making sure it's nutritionally complete. Lots of work ahead.
Sure, sure. Lots to figure out still. But the big takeaway for now is scientists are seriously working on making food in space, using bioreactors to grow the essential nutrients, partly to tackle those huge costs.
That sums it up well. And what's really fascinating, looking even broader, is how this space tech could potentially loop back and help us here on Earth.
How so?
Well, think about sustainable food production, resource limitations, feeding people in challenging environments here, the tech being developed for space. It could offer insights, maybe even solutions.
Ah, interesting. That crossover potential.
Exactly.
Yeah.
And maybe that leaves the thought for everyone listening. If we can figure out how to grow the building blocks of food in an extreme closed-loop system like a spacecraft,
Mm.
what does that teach us? What possibilities might that open up for tackling our own food challenges right here on our planet?